back to my channel. This is Anna 10 Pencil, and we are on day 12 of this Juleetcode July LeetCode challenge, where I am trying to solve every single question in Python. I do have my hefty, trusty mascot with me. It's Jojo Exotic. I feel like you guys need to see her. She was just in the last video for just a hot second. Jojo, say hi. She hates it. There you go. She has been so helpful tonight. So I went through this question once, and I am going to start this timer pretty soon once she clears out of the way. Anyway, okay, so day 12 is number 802. Find eventual safe states. Let's get into it. So the question is, there is a direct graph of n nodes, with each node labeled 0 to n minus 1. The graph is represented by a 0-indexed 2D integer array graph, where graph I is an integer array of nodes adjacent to nodes I, meaning there is an edge from node I to each node in graph I. A node is a terminal node if there are no ongoing edges. If the node is a safe node, a node is a safe node if every possible path starting from that node leads to a terminal node, another safe node. Return an array containing all safe nodes of the graph. The answer should be sorted in ascending order. You guys know how much I love sorting things in ascending order. So example number 1, this is how they are showing you this. So then they give you these examples here. And I did read through those. Actually, I forgot to start this timer. Sorry, guys. Yeah, so we see that only 4 here of this graph is a safe node. So this is pretty cool. And these are the constraints. I haven't read through the editorial yet. Also haven't looked at any solutions yet, and have yet to submit. So, well, we should start out how I love to start out everything. So for these nodes, we also have to figure out which ones have been visited. So I think right away, what we should do is, I think n equals the length graph, and that would be the number of nodes in the graph. Then we should go to visited, which would be 0 times n. So that's the visited status of each node. And then the result, which would be basically a list to store all of the safe nodes. Yes, all the safe nodes. So then we'll go into kind of like an if a safe node is visited, then we return true kind of thing. But just right off the bat, that's what I'm thinking we should do. So this will essentially initiate that graph. So let me go here. So this is the number of nodes in the graph. I say 0 times n, and that's the number of times, yeah, n is node, just double checking, the visited status of each node. And then we have the result, and this is where we're going to store all the results. Sorry, let me try that. Cool. So let's go into the function that it's going to be called isSafe. So it's basically going to determine if a given node is safe or not. So isSafe node. So we're going to say if visited, so if a node has already been visited, it's marked as safe, right? And if it hasn't been visited, then it's marked as unsafe. So that's going to be like a 1 or 2, true or false kind of situation. So we're going to say if visited, typos I feel like I'm about to have in this zone node. And this one will be true. So 1, return true. If visited node equal to 2, then we'll return false. And then we should do visited node equals 2 to mark the node as being visited. So say visited node 2. Okay. And I did something like this a little bit with I can't remember if it was in the 20s or if it was the last day of, what's it called? Juleetcode. But we want to use, what's it called? Guys, what is it called? The neighbor. The neighbor. Oh my gosh. It's 11:24 where I am. I've been doing a couple of these, so bear with me. Okay, so visited node. We want it to be marked. We don't need it to be marked, do we? Because that marks it already. You guys just ignore me. Okay, so for neighbor in the 2D graph, right? Yeah, graph I. For this case, we're going to say is node. So we're going to say if not is safe, neighbor, then return false. Okay. So that, sorry, I should have explained this. This is going to recursively check this area is going to recursively check all of the neighbors of the node by calling the isSafe function to each neighbor recursively. And if I could spell false, it would be a great day for all of us. Oh my gosh. So this is for visited. We need to do if it's marked as safe. Should I put it up? No, because it needs to check. Duh. And then that's going to be 1, and that will be returned true. Yeah. So basically, if all of the neighbors are found to be safe, it marks that as safe. Okay. So that's the other thing is I've been neglecting this decodization. So let's iterate over each node index of I from here. And yeah. So then for each, hold on. So we're going to say for I in range n, if is safe, I result append I. Then we'll return result. Let me just go through this one more time. So there's a dedicated graph of n nodes, with each node being labeled 0 to n minus 1. The graph is represented by an indexed 2D integer array graph, where the graph I is the integer array of the nodes adjacent to node I, meaning that there's an edge for that thing. A node of a terminal node. Shown an array containing all the safe nodes of the graph. The answer should be in ascending order. Okay. So here we have the number of nodes in the graph. Then we visit the status of each node. We have a list to store the safe nodes. I feel like I'm not doing this right in terms of ascending order. So we use is safe. And if it's visited, it's good. If it hasn't been, it's not. We mark it as visited. We check to see if it's safe. Turn to safe. I guess in theory it would be in order, right? An array containing all the safe nodes on the graph. The answer should be sorted in ascending order. Let's run it and see. This should work though. Runtime error. What's my runtime error? Return true. Maybe not. Maybe I don't return true for that. I'm also going to put that there because that wasn't, I didn't space that right. How is that not right? Unexpected indent. Duh. Duh. Okay, wrong answer. So, what do I have? Okay, so it's just not reading anything. Okay, so I had some nuancy things somewhere. Let's figure out where. Didn't mean to move that. Okay. So 0 by n length of graph. This feels right. I'm going to ignore this. This also feels, yeah, if visited, node to enter or return false. This is true. So there's just something I'm missing. If it is that I am going to lose my mind. We're just going to check. Still the wrong answer. Listen, guys, you never know, okay? I always want to pretend. Okay, return visited node 2, which marks that as being visited. Okay, so for a neighbor in graph node, if not is safe neighbor, return false. Which that also makes sense. So the visited node is 1, which is 2, and that, or which is round 1, which is true, and returns true to mark it as safe. So for I in range. Interesting. I'm not seeing where I had an issue, and there's nowhere for me to get a hint. Okay. Steph is safe if visit node. Could it be the visited status of each node? Should I have done something different there, maybe? If visited node, that's just saying if it's true or false. It's not. I'm going to run this like that. Still wrong. Is safe. Could this? Because if I'm looking at how this sits, it should be, that's going to be wrong too, isn't it? Oh, I was right. It wasn't a spelling error. It was me indenting things incorrectly. What a great day. What a great day. It took us 13 minutes, but it took us most of that time to figure out why. I also did misspell visited and like 5 other things. But digressing, it's also 11:34 p.m. I'm tired. I just want to get this done. So this is nothing unless we submit it together. And that's what we're about to do. Internal error. All right. Completion streak, 12 days. Let's go. We love to see that. We love to see that, though. Memory, runtime. Ooh, she fired. She fired. She's nice. She is nice today. Okay. So aside from me not indenting things or me indenting things incorrectly and then misspelling visited and a couple other things and trying to logic into my head, we did pretty well. In 13 minutes and 53 seconds, I would obviously tack on another couple minutes because I did read through the question first and then we started a little late halfway through the question. But that feels pretty good. That feels pretty nice. It all kind of makes sense. So yeah, thank you guys so much for watching. I appreciate it. I hope this answered some questions. I'm going to have the GitHub LeetCode repo link in the comment section down below. You're more than welcome to fork and clone, make it better, make it worse. It's going to be kind of hard to beat. I'm just kidding. You guys, it's all about having fun and learning something and maybe prepping for interviews. I know that's what I'm doing. That's why I'm making these videos, so I get better at talking about these things and explaining these things. So thank you guys so much for watching, and I will see you guys in the next video. Have a great rest of your night.